Okay, here's problem 2. We first need to graph this and sketch the graph, and we need to go along this domain. So I'm going to go ahead. I actually did this before, so I kind of have an idea of what it looks like. So I'm already going to go ahead and set up my x and my y axis. If you go ahead and put these into your graphing calculator, you can see how much space you need. It doesn't really go below the x-axis very far. So we mostly need the second quadrant. So I'm going to go ahead and set this up. This is going to be 0.5, 0.5. This is going to be -1, -1.5. So we're going from here over to 0.5, which is over here, and then we're going to go, I happen to know that it goes up to about 1. So that's as far as I need to go. All right, so let's go ahead and put these into the graph. So I'm going to graph cosine of x squared, and I'm going to graph e to the x. Oops, got a lot of glare on that. Where can I put it? There it is. All right, so let's graph that. Here it is. Notice I had already set up my window. So if your window doesn't look like mine, let me show you what I have on my window. But I already did this problem once, and I made a video that lasted way too long because I was playing around with the video. So notice what I did. I knew that my domain went to -1.5, so I made my window go a little farther to the left, to -2, and I knew that x went to 0.5, so I made it go a little farther to the right. I then put in I wanted tick marks every 10th of a unit, so that I'd have lots of tick marks, just like this graph paper. And then for the minimum on the y, well, I actually graphed them, and I saw that I didn't need to go up very high or down very low. And then again, I put tick marks every 10th of a unit. All right, so that's how I got that. Now, to graph this, I want to know what is my value at the ends of the domain. So I'm going to go second, calculate value, and I'm going to put in the ends of my domain. So -1.5. Notice that gives me the ending point of my blue curve here, which is my cosine. So that is -1.5. I get -0.6. So 1, 2, 3, 4, 5. Oops, it's kind of down here. So maybe I should have given myself a little more space. And notice this. I can jump to the red curve by using the arrows. So I'm going to jump to the red arrow, the red curve, by pressing the up arrow. So its ending point at -1.5 is at 0.22. So this would be 0.1, 0.2, a little higher than that. Okay, so that's going to be the e to the x, and this is going to be the cosine. Okay, now I need the other end. Calculate value. The other end is going to be at 0.5, so put in 0.5. Gives me the blue one first. It's going to end at 0.97, so close to 1. So this is going to come up from 0.5. It's going to end up very close to 1. And then again, if I hit the up arrow, I can jump to the other curve. And that's at 1.65. So 1.5, 1.65. It's going to end there. Okay, next I want to know where are they crossing each other. So I'm going to go to intersection. And let's go ahead and do this intersection first. Intersection. Those two, they are crossing at 1, y is 1. And look at that, that -7.72 e to the -16, it's basically 0. That's an incredibly tiny, tiny number that's basically 0. So they're crossing at 0 and 1. So they're crossing right there. And let's find the other intersection. Move over. Enter, enter, enter. Those are crossing at -1.1, so -1.1 and 3.3. 1, 2, 3, and a third about. That's the other intersection. Okay, so I've got this curve is going to be going like this. Oops, I don't need to go past -1.5. Let's get rid of that. And the other curve is going to be going through here, here, here to here. So it's going to be going up and down a little bit, like that. So there we go. So I sketched it. So remember what I did. I used the end of my domains. So I used the value feature under the calc menu. I found the value for y when x was negative 1.5 and when x was 0.5, and then I graphed these 2 points and I graphed these 2 points. I found the intersections. So this one was negative 1.11 comma 0.329. That's that intersection. And this intersection, it was basically 0, 1, 0, 1. And interesting thing, I can do a value and ask for what's the value when x is 0, and I get 1, and if I switch to the other one, I also get 1. So they really are crossing at 0, 1. It's just when my calculator approximates it, it actually gets a little bit off of the actual location, which is kind of weird. All right, so I've graphed them. Now I want to find the area enclosed. So that's this area here. To get area between a curve, all we have to do is set up an integral from one intersection, negative 1.11, to the other intersection, 0. We only want the x values. And we're going to integrate the top function minus the bottom function. So notice which function's on top. It's the cosine. So cosine x squared. And I'm going to subtract the other function and dx. So now I'm going to use my graphing display calculator to do the rest of the work. So I am going to go back to my y equals, and I'm going to put these on one line. So cosine x squared minus e to the x. And then I'm going to ask it to find the area. So when I subtract the two functions, notice I get this little guy. So then I'm going to calculate number 7 from negative 1.11 to 0. There, it's showing me the area. So it's 0.282. So the area is equal to 0.282. Notice it is asking me for an area this time. It's not asking me for like a total distance. This is not a displacement or total distance problem. So I'm going to give units on this, units squared. And there it is. So the things you need to do is make sure you're being really careful about paying attention to the domain, graphing those endpoints, which is really easy using the value feature, finding the intersection of those two curves because you need those on your integral, setting up your integral, and then you can let the calculator do the rest. All right, that's it. So value when x is 0, and let's jump to the other line. It's also at 1. Great, so they're going to intersect here. So now I can just sketch this on. Oh, and I need to figure out where it ends. So again, value at 0.5. Jump to the other line, 1.65. So 1.65, so about there. There it is. Okay, so I've sketched the two curves. And now I want to find the area enclosed right here. So I drew a sketch. Now I want to write how I'm going to figure this out. I'm going to integrate. To get the area between two curves, I need to integrate the top curve. That would be the cosine one. This one is the cosine one. I'm going to integrate cosine of x squared minus the lower one, minus e to the x. And I'm going to integrate it from their two intersections. So I need to figure out where they're crossing each other. I know here they're crossing at 1. I know that x is equal to 1. But I need to find this intersection also. So this intersection right here, I'm going to find that on the graph. So I'm going to go second, calculate intersection. And I want to get close to the intersection before I tell it to do it. So I'm moving the cursor over. Now I'm close to it, enter, 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 and it gives me the intersection is at negative 1.111. So negative 1.11 at 0.329. That's the intersection, but I only care about the x coordinate because that's where I'm going to integrate from this x over to this x. So, sorry, not 0, negative 1.11. Negative 1.11. So I'm going to integrate this. And notice the whole curve, the whole thing is, oh, actually, this doesn't matter. For between curves, I don't have to worry about any of it being negative because it automatically takes care of that when I'm going in between two curves. All right, so no worries. So now I'm going to I'm actually going to, sorry, what am I going to do? I'm going to go to y equals, I'm going to go to y equals, and I'm going to put this in as one equation minus e to the x. Putting it in as one equation. Okay, and I'm going to graph that. And then I'm going to ask it to find the area from negative 1.11 up to 1. So now I'm going to use my graphing display calculator to do the rest of the work. So second, calculate 7, and I'm going from negative 1.11 up to 0.329. And there is my area, and it is approximately equal to 0.22. Oops, wait a minute. Something went wrong because I got a different answer before. Did I put in the right number? Let me see if I put in more digits. Maybe I need to put more digits in here. Let me go to that intersection again. Oops. Y equals, sorry, I just messed it all up. And e to the x. I got a different answer when I did it before, so I'm thinking maybe I put in more digits before. So let's put in more digits. 2, find the intersection, get close to the intersection. Enter, enter, enter. Okay, I'm going to put in more digits. So instead of negative 1.111527, let's put the whole thing in. Okay, back to my y equals minus e to the x. Now let's integrate it. Oh, I know what my problem is. I put 1 here. The coordinates of this point is 0, 1. That was my problem. I put the wrong number up here. Wow, this is like a really bad video. I should probably start over. Okay, so let's do that again. Second, calculate number 7, and I'm going from negative 1.111527, and my upper limit is 0 because x is 0. There it is, and it is 2.82, which is what I got the first time I did it. Okay, clearly I need more of this because I am not thinking straight. All right, sorry about that. That was way longer than it needed to be.